Talk here a little bit about the end of the semester. So we have 3 class days left. So those 3 class days, we're going to do 3 lessons from Chapter 5. Included in there is a homework quiz. I'm going to drop the low homework quiz. That's kind of already set up to happen, but I've put the new homework quiz in as a missing, so like it hasn't really done anything because all the missings are the ones that get dropped. So that's, you'll see a big jump when that actually a score goes in for that, but that'll happen sometime this week. I've set up to drop your a low assignment. Right now, that last assignment or last assignment check of the semester I've put in also as a missing, so that'll be what is currently dropped. When that last assignment goes in, you'll see a little bit bigger bump than usual as that occurs. Just as an FYI, that last homework check of the semester is going to happen on the Tuesday of the 15th. That's our last day of class for the semester. So rather than having 2 homework checks for the B class that has class on Monday, I'm going to do 1 homework check instead of it being Sunday at midnight. It'll be like Monday at midnight or whatever. So there's that. And then I'm also going to double your high test score. Or, if you prefer, I'll give you the option to retake one of the chapter tests. So if you elect to do the retake, your max score you can get would be the lowest of your other test scores, or a 75%, whichever is higher. If you do worse, I will put in the worst score. And you need to email me by 8 a.m. on Friday if this is something that you want to do. You'll do that during the exam period on the 15th. So that option for the retake is mostly for the kind of student that's like, oh, I got like 75s on 3 of the tests, and I got a 41 on 1 of them, where I just was like kind of out of it that day. In that case, the retake would be much more valuable than a double test score. If you're somebody that's gotten like all A's and B's, the double test score is going to be just as valuable as a retake would, particularly since I'm capping, at the next lowest test score. So think on that. I've already put in I'm putting in the doubled high test scores today, so you can kind of see where things are at. You don't have to make any decision until Friday at 8 a.m., but at Friday at 8 a.m., if you're somebody that wants to do the retake, you need to email me and tell me what chapter you're going to plan on retaking. If you just want to take your doubled high test score, you don't have to do anything. Okay, everybody gets that for free. Are there any questions about that end of the semester stuff? So the 15th is our last day of class. That's technically the assessment period. Everybody needs to show up, but unless you're doing one of these retakes for an old chapter, you won't be here for very long. We'll just kind of say hi and cross some T's and dot some I's and get you out of there so you can study for whatever might be coming up next. Also worth pointing out that homework check on the 15th is going to be the very last time you have an opportunity to turn in any homeworks. So if it's not done on the 15th and like I can see it on the 15th, I'm not going to go back and recheck things after that. You have to have it right on that day, or if you have anything that's missing, still outstanding, got to have it in for that one. Okay, so the 15th is going to be the last day of class. That's the due date for the very last homework check. It's got to be in, and it's got to be visible for me. If I can't see it, even if it's in your notebook and you didn't sync it properly, I'm not going to count it, because I'm not going to go back and look at things a bunch of different times. So make sure that if you're doing that stuff, that you sync after you put your homeworks in there and all that, that it's good. Okay. All right. Everybody, does that feel fair to you guys? So I've started doing some of those things already, and as they kind of, as we continue to kind of add in those last few assignments, you'll see great improvements, coming throughout. So I think I put in your double test score already. I've been in the process of doing that for several classes today, so I can't remember whose I've gotten to, if I've gotten yours in there yet or not already. But if you see an error on that, please let me know as well. Okay. Today, then, we're going to start Chapter 5, which is all about polynomials. And there's really just a few topics that we're going to touch on in Chapter 5 this semester. All of this will continue in Chapter 5 in second semester, so anything we're doing now, we'll kind of review at the start of next semester, but you do need to, learn it now, because we're going to go through it faster than we would if we're teaching it the first time. So the topics that we're going to look at here, these last 3 class periods, we're going to do addition and subtraction of polynomials, multiplication and division for polynomials. We're going to talk about synthetic substitution, and then factoring and solving. But each of those are just, we're going to do like a partial treatment on each of those, because we'll do, the bulk of, in second semester, the bulk of our time in Chapter 4 is going to be spent kind of continuing to talk about factoring and solving, because these are quite rich topics that we'll just do a little bit of a treatment here in first semester, talking about some things that we can do that are very similar to what we did with quadratics, before we kind of extend that into some more interesting techniques that are not really related to quadratics in second semester. Okay, so we'd already spent some time at the beginning of Chapter 4 talking about some vocabulary as regard to polynomials. So we talked about like degrees and leading coefficients and leading terms and constant terms and all that jazz. I'm not going to rehash any of that now. But mostly today, what we're going to talk about: addition, subtraction, multiplication, division, synthetic substitution. We'll come back and do division again tomorrow, because there's some more involved there, but I don't want to do it all in one day because it gets to be a little confusing for students. So these are the three kind of things that we'll talk about here today. So, example. So let's say we have a polynomial. and a second polynomial. Actually, let's say that then. So let's say we want to add these two polynomials. The way we write the addition of two polynomials, if we're adding the polynomial f and the polynomial g, we do f plus g of x. The nice thing about polynomials is that polynomial that's the sum, we can just find as the sum of the two individual polynomials. So that's quite nice. So really all we're doing is 3x cubed minus 2x squared plus 7x plus x to the fourth plus 3x cubed minus 2x plus 6. So here all I really need to do is to kind of collect the like terms together. So I have x to the thirds that are like terms. Remember, when we add monomials like this, the coefficients we add, but the exponent stays the same. So 3x cubed and 3x cubed becomes 6x cubed. And the other pair of like terms we have is the 6 and the 7. So 6 plus 7 is 13. But there is no like term pair for any of these pieces. So they're not going to change. We'll just write them down. And typically, when we write our polynomial, we want to write them in standard form. So we'll write them from the biggest exponent down to the smallest exponent. Well, this would be our answer. Any questions about that? Okay, that's good. So let's do subtraction then. So the way we write subtraction is f minus g of x. And again, just like before, we can find that difference by just subtracting the two polynomials. Here, though, the thing that we need to be careful about is that when we subtract g of x, that negative sign needs to be applied to all of g of x. So we need to make sure we distribute that negative through. And now that we've distributed that negative, we just need to kind of combine our like terms. So (3x squared or 3x cubed minus 3x cubed is 0. So I don't have to write anything there. And then 7 minus 6 is 1. And then these pieces don't have like term pairs, so we can just write them down with no change. Oops. Look at me as a dummy. I forgot the squared on this guy. I wrote that down wrong. I just forgot to write the squared on that. My apologies. Okay. I was like, wait a minute, we have another like term. Where did that other like term come from? It's not supposed to be there because I copied it down wrong. Forgive me, it's 8 or 9:30 in the morning. Okay. And then lastly, we like to rewrite this in standard form where the exponents go big to small. Okay. Any questions there about the subtraction? Okie dokie. So let's do multiplication. So again, as we've seen our pattern here, that if I want to talk about the product of two polynomials, I can just multiply those two polynomials together directly. And one way we could multiply these polynomials together is basically I can multiply each term in my first set of parentheses to each term in my second set of parentheses. I do that. And I do that. And then I do that. But woof, that's starting to look like quite a mess there. I have a lot of terms to do, a lot of little multiplication problems to do. It's easy to forget to do one of them or to do one of them incorrectly, and it's becomes a little bit overwhelming. So what I'm going to do is I'm going to kind of organize my work for this in a kind of a different way. So I'm going to build like a little grid to kind of do my work. So I'm going to take one of my polynomials in my grid and write it kind of as the vertical column. So that's this polynomial, but you'll notice that I did something here. If I look at this polynomial, you'll notice we go from x squareds to constant terms with no x term. So I've gone ahead and written in a 0x because we don't have any x's. And I'll show you why it's helpful to do that here in a moment. But we'll want to make sure that we do that as it makes life quite a bit easier. And then on the other side, the horizontal, I'm going to write in my other polynomial. And just like before, I notice this one doesn't have any x squareds. So I'm going to include that 0x squared there. Now I'm just going to turn this into like a grid. Okay. So the idea here, each of these squares in my grid represents one multiplication problem. So for this first square, to get the answer to go in there, I'm going to multiply one side by the other side. So 3x cubed times x to the fourth. Remember, when we multiply monomials together, we multiply the coefficients together. So 3 times 1. And then we add the exponents. So 3 plus 4, 7. So if I go to the next spot, here we're going to do those two multiplied together. So 3 times 3 is 9. And then 3 plus 3 is 6. So I have 9x to the 6th. And I just am going to kind of continue doing this. So I'm going to go and start filling in the rest of this. So I'm going to stop saying what I'm writing. Because if you guys are copying and you're at a different spot than I'm saying, it gets very confusing when somebody's saying numbers when you're trying to write down a different number. One of the famous annoying tricks you could play on somebody when they're counting is to just start yelling random numbers out. Really confuses the heck out of them. I think that was one of the plot points in Home Alone that allowed Kevin to get forgotten. As while one of the siblings was counting, another one was yelling, random numbers. I think Buzz was the culprit there. It is Home Alone season, so my suspicion is that one or more of us have watched Home Alone recently and might get this reference that I'm talking about. But if you don't, no harm. I'm basically just kind of filling time while I fill this stuff in, just so it's not weird and silent. So, if we take a look at the grid here that we filled out, you'll notice there's a couple of patterns going on with the exponents. So if I look up and down my table, the exponents decrease as I move down the table. So for example, if I look at the first column, I have 7, then 6, then 5, then 4. Similarly, as I move from left to right across the table, my exponents also decrease. For example, in the first row, I go from 7, 6, 5, 4, 3. So one advantage of putting the zeros in is that kind of make sure that pattern is maintained, that we're always kind of decreasing by 1 as we move left to right or top to bottom across our grid. The better piece, though, comes from when it's time to find our like terms. So if you notice here that our like terms are all now on these same diagonals. So it's very to locate our like terms to kind of add everything together. So our first loop there is just 3x to the 7th. And I have negative 2x to the 6th and 9x to the 6th. So when I add the coefficients, I get positive 7. The exponent stays the same. Then 0x to the 5th, negative 6x to the 5th, and 0x to the 5th. Well, just negative 6x to the 5th. And 7 and 0 and 0 and negative 6 would be 1 x to the 4th. 21, 0, 4, and 18 is 43. And then 0, 0, and negative 12 is negative 12x squared. Negative 14 and 0 is negative 14x. And then 42. Now again, drawing this grid is doing the same thing that we kind of did before, where we're just kind of multiplying every term in one polynomial to every term in the other polynomial. It's just a more effective means of kind of organizing that information so that it's easy to make sure that you do all the little multiplications. And it makes it easy to kind of collect the like terms because the like terms are all kind of in a diagonal. You don't have to go hunting through a big line of, in this case, what do we have? 20, or if you didn't include the zeros, 12 terms to kind of sort through, like, oh, where are my like terms at? Ooh. It's all taken care of. So that's quite nice. Okay. Next thing we need to talk about is division. But before we talk about division of polynomials, I want to talk about long division. So you have to think back to your elementary or middle school days when you did long division. I'm not positive really where that happens at. Let's say we have 3,517 divided by, 16. So if you remember, way back in the day, we go and we take the divisor, that's that second number, and we put it outside of our division bar, and we take the dividend, that's the first number, and we would write it underneath that division bar. And then we would go and ask ourselves, okay, how many times does 16 go into 3? Well, none, obviously. So we move to the next spot and go, how many times does 16 go into 35? Well, that's 2. So 2 times 16 is 32. And then we would subtract down. And bring down the next digit. And we'd ask ourselves then, how many times does 16 go into 31? Well, just one time. So 1 times 16 is 16, and then we subtract down. And we bring down the next digit. And the last question we'd ask then is, how many times does 16 go into 157? That's 9. 144. Subtract down. That gives me 13. So we'd say the remainder is 13. So the way we would write our answer then is that 3,517 divided by 16 is 219 plus 13 over 16. So this number here is called the quotient. The 13 is the remainder, and we always write that over the divisor when we write our final answer. So you guys remember doing long division, your elementary or middle school classes. I can't remember where that happens, like maybe 5th, 6th grade is when you start doing that. And you probably did it for a couple of years till the numbers got kind of big or whatever. I'm not sure. I don't teach middle school, but when you stop doing that, but it's something you should kind of remember. So let's do an example now with polynomials. So polynomial division is very similar. So let's say we want to take 2x cubed minus 7x squared plus x minus 4 and want to divide it by x plus 2. So we'll set up this problem the same way we did before. So we'll take our divisor, write it outside of our division bar, write our dividend underneath our division bar. So that's kind of our initial setup. But polynomial division differs a little bit from long division. So the first question I'm going to ask is really only involving, or every time we ask this question anyways, it's only involving the leading terms. So I'm just asking how many times does x go into 2x cubed? I'm going to ignore the plus 2 for now. Well, I know 2x squared times x would give me 2x cubed. And then I'll multiply that 2x squared to both parts of my divisor. We'll multiply it to the entire divisor. That gives me 2x cubed plus 4x cubed, or squared, excuse me. And then I need to subtract that. Now, this is the place where students will frequently make a mistake, because oftentimes I see students forget to distribute their negative sign. So instead of writing this as negative of the quantity, let's distribute that negative through. And then we can just add straight down. So 2x cubed minus 2x cubed is 0. Negative 7x squared minus 4x squared is negative 11x squared. And then we can bring the next term down. Then we'll ask ourselves, how many times does x go into negative 11x squared? Because that's our new leading term. Well, that's pretty easy. I know that a negative 11x times x gives me negative 11x squared. So I'm going to multiply negative 11 to the entire divisor. So negative 11x times x gives me negative 11x squared. And negative 11x times 2 gives me negative 22x. And then we'll subtract down. But before we do that subtraction, we should distribute that negative. So negative of negative 11 becomes positive 11. And negative of negative 22 becomes positive 22. So negative 11x squared plus 11x squared is 0. And x plus 22x is 23x. And I bring my next term. And then I ask, okay, how many times does x go into 23x? Well, that's easy. Just 23. So 23 times x, and then 23 times 2 gives me 23x plus 46. And then we need to subtract down. So when I distribute the negative, they both become negative. So I have 23 minus 23, that's 0. And then negative 4 minus 46 is negative 50. So that's my remainder. So we'd write our final answer then is the quotient, so 2x squared minus 11x plus 23 plus our remainder, which is negative 50 over the divisor, which is x plus 2. So very similar to what we did with long division. Let's do another example of that, because that's not trivial, right? That's a fairly complicated procedure. So let's look at that again. Okay, so let's say we want to do negative 3x cubed plus 7x minus 6 divided by x minus 3. So we'll set this up the same way. So the divisor, x minus 3, goes outside of the division bar. And then under the division bar, we have to be a little bit careful here. If we look at the polynomial negative 3x cubed plus 7x minus 6, you should notice that's a little bit different than our dividend from the previous problem, because you notice that there's no x squared term here. So when I write my dividend here, I'm going to include a 0x squared for that missing x squared term. And really, it doesn't matter what term is missing. We just are going to put a 0 in that spot. And it doesn't matter if the term is missing in the dividend or in the divisor, or both. We're going to include zeros for every time there's a missing term, wherever that missing term may be, no matter how many missing terms there are. They're all going to get a 0 with whatever the x is that it needs. Okay. So we're going to start, we're going to go, okay, how many times does x go into negative 3x cubed? Well, I know negative 3 times x squared times x gives me negative 3x cubed. So then I'll multiply that to the entire divisor. It's going to give me negative 3x cubed plus 9x squared. And then we'll subtract down. But remember, again, we're going to distribute that negative through. So negative times negative is positive. Negative times positive is negative. And then we can just add straight up and down. So negative 3x cubed plus 3x cubed is 0. 0x squared minus 9x squared is negative 9x squared. We'll bring down the next term and start over. So now we'll ask, okay, how many times does x go into negative 9x squared? Well, the answer is, I know negative 9x times x gives me negative 9x squared. So I'll multiply that to the entire divisor. Negative 9x times x is negative 9x squared. Negative 9x times negative 3 is positive 27x. And then we'll subtract down. But we'll want to make sure we distribute this negative sign through. So negative of a negative 9 becomes positive 9. And negative of a positive 27 is negative 27. And we can just add straight up and down. So negative 9x squared plus 9x squared is 0. 7x plus a negative 27x is negative 20x. And we'll bring that negative 6 down. And our last question is going to be, how many times does x go into negative 20x? Well, that's just negative 20. So I'll multiply that to the entire divisor. Negative 20 times x is negative 20x. Negative 20 times negative 3 is positive 60. Oops. I was writing those in blue. And then we'll subtract down. So again, we'll make sure to distribute this negative. So negative of a negative 20 is positive 20. Negative of a positive 60 is negative 60. Negative 20x plus 20x is 0. Negative 6x minus 60x is negative 66x. I'm sorry, no x's, just negative 66. So that's our remainder. So we'd write our answer as our quotient plus our remainder over our divisor. Okay. The last thing that we want to talk about today is this synthetic substitution. But before we get to that, let's remind ourselves what regular substitution is. So let's say we have the polynomial f of x equals negative 3x cubed plus 7x squared minus 3x plus 10. And we want to find f of negative 2. What that means is that we just want to put a negative 2 in everywhere where we had an x. So that's going to be 24 plus 28 plus 6 plus 10. So that is 68. Okay, so that's just what regular substitution is. So synthetic substitution is another method to do the same thing. So the result of this synthetic substitution is going to be this number 68. So we're going to do the same problem, but we're going to do this as a synthetic substitution problem. So the way this works, we start by setting up the problem with like this kind of L-shaped little grid here. On the outside of our L, we're going to put that number that we're substituting into our polynomial. And then the numbers inside of our L are going to be the coefficients from our polynomial. So that's our setup. Now comes the synthetic division process. So the first step in this process, we're just going to take that very first number and we're going to bring it down underneath our division, or underneath our synthetic substitution bar. Once we've done that, now we're going to take this number on the outside, multiply it to the number underneath, write our answer here, and then add down. So -2 times -3 is +6, and then we're going to add down, so we're using black here, to get 13. And then we're going to now repeat that process 2 more times. So -2 times 13. And then write our answer here and add down. So -2 times 13 is -26. And I add -3 and -26 is -29. And one more time. So -2 times -29 is 58. And 10 plus 58 is 68. This last number is what we're looking for. That's going to be our answer. And you might be asking, whoa, this is one convoluted method for doing something that seems relatively easy to do. And you're right. The advantage here of this method is that we can use this to do things other than just substitutions. So the substitution here becomes a nice way for us to learn this technique, because we can use this to do other things that are not as easy as substitution. Because it turns out these other numbers down here can have some meaning if we're looking at it in the right context. And we'll talk about that tomorrow, about how we can use this synthetic substitution to do something else. But let's do one more example of this synthetic substitution before we go. This will be the last thing that we do today. Okay, so let's say we want to do the polynomial g of x equals -3x cubed plus 2x squared minus 7, and we're substituting in a -3. So the -3 goes on the outside, and the coefficients here, -3, +2, and then not -7, not yet. 0, and then -7. Why, oh why did he put a 0 there? Well, notice in our polynomial g of x, there is no 0, or there is no x term in that polynomial, So I need to make sure I include a 0 there in its place. Number one place that students make mistakes is doing something like this. Well, we'll begin by bringing down that first number. And we'll do the number on the outside times the number underneath. So negative 3 times positive 3, or sorry, negative 3 times negative 3 is positive 9. And we add down to get 11. And we just keep repeating that process now. So negative 3 times 11 is negative 33. 0 plus negative 33 is still negative 33. And then negative 3 times negative 33 is positive 99. And negative 7 plus positive 99 is 92. That's the answer that we're looking for. So whatever that last value is in our synthetic substitution table there is going to be the value that we're looking for. Any questions today? Okay, very good. So your assignment here is in the content library on OneNote. So I've given you a couple of polynomials, and then I ask you to do some vocab. So just review those vocab concepts to write down the degree, the number of terms, leading coefficient, the leading term, the constant term. Then I have an addition problem, a subtraction problem, and a multiplication problem. And then I have 3 synthetic substitution problems and 3 polynomial division problems for you guys to practice with. Okay. So any questions about this? No. Okay, very good. So we're done today. So you guys